Welcome to my YouTube channel today. My name is Kwabena, and today we are going to be looking at memory caching techniques. So please make sure to like and subscribe my channel. Let's get right ahead into it. So before we get into the techniques, I like that to get a brief understanding of four caches. So it's a high, as you can see on the text on the screen, it's a small and high-speed memory located close to the CPU, and it stores frequently accessed data to reduce access time. And you may say it's just it does just the same job as the RAM, but then the RAM is a bit slower than the CPU because the CPU it's a bit too slow for the CPU. But then the cache, it bridges the speed gap using locality of reference. And we have the temporal and we have the spatial cache. The spatial access data near recently accessed memories, while the temporal it keeps on using recently accessed data. So these are the three primary techniques for cache here. So we have the direct mapping, we have the fully associative mapping, the set associative mapping, and each of them determine how a memory block is placed in a cache. As you go ahead, you understand what a memory block is, and you'll be able to grasp a better idea of what I'm saying. So for the direct mapping, each block of memory maps to exactly one cache line, and the address is divided into tag, index, and offset. So what are tag, index, and offset? So tag is the address that you get when you've considered everything to the index and the offset. The offset is a set of blocks of cache lines, whilst the index it determines the exact bit. Sorry, the offset determines the exact bits of a data cache, whilst the index determines the exact blocks. It determines the exact blocks of data cache. So the tag is what you get after you've considered both the index and the offset. So some of the pros of the direct mapping are it's simple and fast. It's simple and also fast here. So I think that's pretty much it. And then for the cons, it has high conflict misses. So you can per your perspective, you can base that on miscalculations and a lot of mistakes. And these are some of the examples of the cache. You have the 4 megabyte cache, the 64 bits lines. Yeah, as you can see, 2 raised to the power 22 over 2 raised to the power 6, which is equal to 2 raised to the power 16 lines. And we have the 32-bit address that has the a tag of 10 bits, an index of 16 bits, and the offset of 6 bits. So the next thing we're going to be looking at is the full associative mapping. And the difference between, I'm sure most of you have already seen the difference between the fully associative and then the direct mapping. With the fully associative, any block can go into any line in the cache, but then with the direct mapping, each block of memory maps to exactly one cache line. So we've already found the first difference between these two. And then another difference is that the address splits into just tag and offsets. The set index is excluded. So some of the pros of fully associative mapping are flexible and has low conflict misses. So per what you've seen till now, you'd prefer to take the fully associative mapping because it already has low conflict misses considered to the direct mapping, because that had a high conflict miss and it's also flexible. But then one of the cons is that it's very expensive and it's a very complex hardware, so you need to have quite a knowledge on how to operate this kind of hardware, and it has a slower lookup time. So that's one of another cons on the fully associative mapping. So the next thing we are going to be looking at is the set associative. So this it compromises of the direct and the fully associative. So it's like I would like to reference it to the metamorphic rock. It's exactly like it, because it compromises of two different mapping. So the cache is divided into sets, and each of them contains a number of lines. So example, if you were to have the 4V, each set would have 4 lines, and then the address is split into the set index, the offset, and the tag. So this with this mapping, you like to say it takes the cons of both the fully associative and then the cons of the direct. So it has a balance of speed and it's also flexible. But then one of the cons is that it's slightly more complex than direct mapping. So the better the mapping technique gets, the more complex it is for you to operate that kind of hardware. So so these are the three mapping techniques. I hope I've been very helpful. I hope to see you guys again next time. Peace out.